Hey guys, Mr. Gardner here, and I'm coming to you today with our Thursday lesson about just interpreting and creating our own scatter plots. So, when we're looking at scatter plots, we've looked at so far just relationships when we're looking at them and how they correlate to each other. Either positive when you have a slope like this, if the scatter plot goes up in that direction, negative if you can see a trend this direction, or if it's just all over the place, you got no correlation. So, positive, negative, and none. All right, but we haven't seen really how to make one yet. So we're going to talk about that today. So if you were going to be doing it, first you want to collect some data. So I already have data here, already collected. And so what this data is showing you is how far away from the epicenter of an earthquake, how intense the earthquake was. So we have intensity here, and we have distance from the epicenter. So you can see that there's going to be data all over the place, right? But we want to see if it correlates in any way. So first what we're going to do is we're going to plot it into our graph. Now I know normally we would put our x values on this side and the distance there. So it's always good just to check how these are labeled, right? We've said that from the beginning. Always check your labels, because in this case, your x is over here and your y is right here. So you always just want to make sure you're looking at that so that you don't plot them backwards. And again, these are in Roman numerals. So just remember that's like 4, 5, 1, 5, 1, 4, 2, 1, 3, 3, 3, 4, 2, 2, and 5. Okay, so we just changed the numbers there. So we'll just start here. Armona, California had a 4 intensity. All right, and it was 89, so it was somewhere down here. Okay, and then we can see the next one. It was an intensity of 5, and it was 35 from the epicenter. So that would be like right down here, a little bit under half. Okay. Let's see, Boise had a level 1, and it was 900 miles away. So that would be up here somewhere. So what, 934? So a little under half of 950. And we're just going to keep doing this all the way through. So Coalinga is 47 miles away, and it was at half. So that would be around here. Okay. And then Denver, 1400 and a 1. And you could probably by this time already start to see this trend that's happening here, but we'll just keep going just to make sure that it fits. So 4, and it's like right at 100, so that would be like right here. All right, and then we would have Henderson, who's 500 miles away, and it's going to be an intensity of 2, so that's like right there. And then Kansas is 2,000 miles away, and it's a 1, so that's going to be like right up here. And then we have Las Vegas now, 482, and it had an intensity of a 3. So like right at about 500 miles. Okay, 778, and it was a 3, so that's like right up near 800. So it'll be up there. We got another Nevada one. It was level 3 at about 400, so that would be a point there. Ranchos Palo Verdes, it was a 4, and it was 294, so right at about 300 miles. Okay, and then we got Salt Lake City is 930 miles away, and it was a level 2 intensity, so that's up here. Sevier, Utah, 781, level 2, so that's close to 800, so we'd put that point right there. And Strathmore, California is 129 miles away, and it's a level 5. So here's 5, and 129 would be around here. And so if we were looking at this, we can see, right? If you're way far away, then your intensity is usually lower. And the closer you get, the higher the intensity. So we could show that there's like a negative correlation, right, to intensity and distance. So as the intensity is higher, distance is lower. Okay, so we get that correlation. Now, the next thing we want to think about when we're doing this is if we could fit a line of best fit. And so the way we would do a line of best fit is we would look for a line we could put through here, a straight line that is going to go through the most points. So you can do this with a ruler. You can kind of eyeball it between a couple of points. And I'm just going to do it with this ruler here. And I'm going to tilt it until I can see it going through a couple of points and being close to a few other ones. So if I look at something like that, right? That one goes through a few points, but if I tilt it maybe a little bit more this way, I may be able to fit a few more points in there. But basically, you just want to try and fit a couple of points in that are going to represent the whole graph. So I would say something more along this line is going to be a little more effective for my line of best fit. So I would say something probably like that, where you can see is that I'm pretty close to a bunch of these ones. And it is representative kind of the trend that's being shown. Now, normally for this kind of activity, we would use a computer to actually do this regression and find the actual line of best fit. But for what we're doing, we're just kind of estimating that line of best fit right now. So you just want to see something that represents. So that's pretty representative, right, of what we have going on. And you can see that it'll average out because some points are above, but some points are also below the line. So those things end up averaging out and giving us this nice line as a trend is called the line of best fit. Okay, and so that would fit good. And again, if we wanted to do this, we could take 2 points on this line and we could create an equation for that line. And so that would be like kind of the equation that represents this. It's not going to be exact, of course, but it's representative. All right, and the other thing we want to talk about is just like points like this, right? This point is way out of the ordinary. It's so far away, but a really low intensity. So it does kind of fit the data, but we would still consider this to be an outlier because it is 1,000 miles away from our other points. So it's kind of out of the scope of our data that we have here, so we probably wouldn't include it. This one is also kind of approaching that outlier range because it's kind of out of our data range. All right, so these would be outliers. They're kind of far away. They don't really represent the data that well. And then also the other kind of thing we could talk about is on this graph is there's a cluster down here. So this cluster is showing like as you are really close to the epicenter, the intensity is higher, right? And that's what you can glean from this because a lot of the points are clustered right around here, which means that if you're around 100 miles away, then you get the most intensity. Okay, and that should make sense with an earthquake, right? If you think about it logically. So this is how you would create a graph and show a line of best fit and to be able to describe the trend. So this would have negative correlation. Right, which means as you get closer, so as the distance is smaller, your intensity is higher. Okay. And we could show a couple outliers. These points are outliers, so we could find those on the map or on our table here. So like this point and this point are kind of outliers from our table. All right. And then we see this cluster, right? This cluster over here at 5. So it would be like this point, and this point down here is kind of a cluster of points, right? They're all within kind of a similar amount of miles, and they're all on that same intensity level. So the way you're going to do this is your assignment is going to require you to measure your hands and to measure your feet, and you're going to make that in a table. So you would do for each person. So let's just kind of move over and get a clear space here. But what you would do is you're going to make a table, and you're going to put hand size and foot size on a table. And then you can make a graph as well. You should do this with the people in your household. So measure everyone one hand and then measure their foot, or you can just put the shoe size there. Either one, that should work. So just see what shoe size they have. And when you're measuring the hand, if we have a hand here, and this is going to be one of my beautiful artwork that you guys are all so accustomed to seeing. All right, you're going to measure from the top of the middle finger to the bottom of the palm is what your measurement's going to be. And you can use round numbers. If it's like 10.2, just put 10 inches for the hand size. You don't have to do anything too complicated. Okay, so try to get at least 5 data points. So let's say you measure somebody and he's got 5-inch hand and he wears size 6 shoe. Right, and then on this one, you just have shoe size. And over here, you're going to have hand size. Okay, and then you're just going to graph them against each other like so. So you'll have a graph set up for you that you can put your points on. So I know my hand size is 5, 1, 2, 3, 4, 5, and then the shoe size is 6 with that. So 1, 2, 3, 4, 5, 6. All right, and we can go up there and just put a point and just do that for everybody in your house to get some decent data. Now, if you can't get enough people in your house to do that with, which can be the case for some of us, I have linked a website here that gives NBA basketball players' hand size and their shoe size. So you can see here, here's some shoe sizes. So you can use theirs. You can use their data and then just match it up with their shoe size. Okay. So got some hand sizes, some shoe sizes. You can go ahead and just kind of match those things up and then create that data for your graph. All right. And if you have any questions, comments, concerns, just come show up to office hours, send me an email, and we can discuss it and help you get through it.